Imagine a time when Earth, our familiar home, was a molten mass of rock and metal, a far cry from the world we know today. This was Earth, some 4.5 billion years ago, a fiery world under intense meteorite bombardment and volcanic activity. As the heat subsided and the surface cooled, a transformation occurred. Dense basaltic rocks solidified to form a crust, the first chapter in Earth's geological story. As the Earth cooled, a solid crust began to form, laying the foundation for the continents we know today. The story of continental formation cannot be told without mentioning one of the most significant discoveries in Earth science: plate tectonics. This theory, simply put, is all about the Earth's lithosphere, the rigid outer layer of our planet, which is divided into a jigsaw puzzle of large and small plates. These plates, akin to gigantic puzzle pieces, are constantly moving, albeit at a pace slower than your fingernails grow. Now imagine these puzzle pieces on a slippery surface, continuously jostling, sliding past each other, or even colliding. This is exactly what's happening beneath our feet. Some plates pull apart, creating gaps filled by magma from beneath, forming new crust. Others collide, with one plate being forced downward in a process called subduction, while the other buckles and folds, creating mountain ranges. Continents form when these massive plates come together or break apart, much like puzzle pieces on a grand scale. Now we come to a crucial part of our journey: the formation of the continental crust. Think of the Earth's crust as two types of cakes. The oceanic crust is like a thin, dense brownie, while the continental crust is more like a thick, fluffy sponge cake. They're both cakes, but with different ingredients and baking processes. For our continental crust cake, the ingredients are various types of rocks from the Earth's mantle. These rocks undergo a process similar to baking. They melt and differentiate or separate into different layers based on their densities. This process forms something called granitic magma, a kind of batter for our continental crust cake. As this magma rises towards the Earth's surface, it cools and solidifies, forming large chunks of lighter, less dense rock. Over millions of years, these chunks accumulate and harden to form the thick, buoyant continental crusts we live on today. Just as a cake takes form from a mix of ingredients, so does the continental crust from the differentiation and solidification of rocks in Earth's mantle. Sometimes the formation of continents involves dramatic collisions and mountain-building events. Picture this: two cars speeding towards each other. On impact, a pileup occurs. Much like this, when two tectonic plates collide, the intense pressure forces one plate down while the other is thrust upwards, leading to the formation of mountains. Over time, these mountain ranges can grow and merge, forming larger landmasses or continents. Much like a car crash leading to a pileup, the collision of tectonic plates can lead to mountain formation, shaping our continents in the process.